Hi guys, Lee here again. Just checking in for another C# tutorial episode. This one will cover quite a lot of stuff, and it will be more based around the actual elements of the C# language rather than just what you can do in the console. So for this tutorial I'm going to start a new project again. I'm just going to start with a console application. I call that tutorial C# types, and then we get our basic project coming up. I'm going to click cancel to that because I don't want this source controlled, and there we go. So in this we're going to cover several elements. We're going to cover number types, which consist of int, float, double. We're also going to cover bool and string, and then we're going to move on to what we can do with them. So that will be an if statement and that will be an else statement. And these are two very basic things that you can do, but that will lead on to very powerful things later on in your development. Okay, so first of all I'm going to show you what these types are. I'm going to come down here and then going to start typing if int I equals 0. So an integer is any number which is a whole number. So an integer cannot have any decimal places in it. So you'll see that if I put this in here, it will complain when I try to compile that that's not an integer. So it says cannot implicitly convert type double to int, and this is because it's got a decimal point in there. If I take the decimal point away and just compile that, it succeeds, no problem. So the next type we want to look at is float, or floating point. This is a decimal point number which is single precision. Now you don't actually need to know what that means just yet, but a floating point essentially has less accuracy than a double, but it also takes up less space in the memory. So if you don't need an incredible amount of accuracy, especially with larger numbers, or you don't need a huge amount of space, use a float. So as you can see, that'll compile. Oh no, it won't compile, excuse me. Right, so you need to put an F after this to make it compile, because otherwise it thinks that any decimal point is a double. So now we move on to this double that everyone's been talking about, and we can just at this point do a number like that and hit compile, and that'll be fine. So as you can see here, that very basically we've got an integer, a float and a double, each represented by the numbers that they can hold, or the data that they can hold. So these are our number types. We now move on to the Boolean, also known as bool. And a bool literally just is true or false. And that's all that a Boolean can contain. So these are very good for if statements, but we'll get onto that shortly. The next type is string, which, as you can imagine, is represented by some text, and that is what a string contains. So you can do quite a lot with a string, and there isn't really a size limit on string, because if you extend over one memory space it will create several more to hold your object. But that's more advanced stuff that we'll get into in a later point. So essentially these here are our types that we're going to be looking at, and these are the most common types as well. These are the default common types within C#. There are other ones, so there are objects and classes and getting into that state of things, but for now these are all the ones that we're going to look at least in this episode. And these are the basic ones that even after 10 years of programming in C# you'll see these on a daily basis. So it's important to really get to grips with these different types. Okay, so now we're going to move on to if and else. Start off with if, and this is literally just to check whether something is true. So this is what an if statement looks like. So it says if, open bracket, my statement, and then close bracket, and then open curly braces and close curly braces. So usually in here you'd see something like my bool, and what that's saying is if my bool is equal to true, then we go into this. Now with certain types you can remove the equals true bit, especially with the Boolean types. So you don't need to type all of this bit, but that is exactly what it is doing anyway. It makes it a lot easier to read if you do take it away, and for the most part people will be quite strict on removing that extra bit, because it's a lot more that you don't need to type then. So we're going to say if my bool console.writeLine, my bool was true. And now also what we're going to do is an else statement off the bottom of this. So we can then type else, new line, and open curly braces. And in here we're going to write the same thing again, except this time we're going to say my bool was false. As you can see, that's a very, very, very simple check to see what the value is of my bool. You can also do this with all of these basic types here. So you can say if I equals 34, console.writeLine, I was 34. Else console.writeLine, I was not 34. And as you can see, there's a very simple check to see whether I is equal to 34. But then in here you can also say if it's greater than or equal to, if it's less than or equal to, if it's not equal to, or then you can just do greater than or less than. We're going to keep it as double equals for now, which is just a simple value check. And then we're going to move on to the float. So I'm going to change that float down to 3.3 just to make it easier to type. And down here I'm going to say if f is equal to, if f is greater than 3.2f, remembering that that little f on the end of the value means I'm a float. I'm going to do console.writeLine f is greater than 3.2. We're also going to do another if rather than an else this time, and say if f is less than 3.4. Now we're going to change that to less than and then 3.4. So I'm going to run this application now, and I think it's going to flash up and go away. And so it did, yeah. So what we're going to do is do a very crude console.read, just so that it waits for our input before ending the application. So click start again, and we can see, so my bool was true, so that's good, because we know that it is true. It also says I was 34, which is good because we know that it was 34. And then down here, in our latest bit of code, it says f is greater than 3.2 and f is less than 3.4, which is good because we know it is. So if I stop running this now, and then we go and change a couple of these. So if it's greater than or equal to 3.4, 3.2, and if it's greater than or equal to 3.4, we'll change that to greater than or equal to, or equal to. I'm going to run that again, and then we should have one less line, which we do. F is greater than or equal to 3.2. But then it doesn't run this code here because f is not greater than or equal to 3.4. Okay, so we've covered all the bases that we wanted to today, and I'm hoping that this was helpful, because there are a lot of things that you can now do with these types. You could go away and practically write a text-based adventure game in your console armed with this information here. I think one thing that you can do as well is to really boost it further is if I remove all of these if statements for a second, just to clean my code up a little bit, and then I say console.writeLine, and then type in here characters, you can see that the Visual Studio isn't complaining about that, and that's because console.writeLine here is expecting a string as its value. So what we can do now is we can click start, and then we can see that it prints out some text. This is getting really long. Oh, that's fantastic, because that means that you can change this value here with code. So you don't need to hard code everything in to be able to print out stuff to the screen. So what I can also do here is plus I, and then we can say health, like that. So then this will print out health 34. And look at that. So on with this now, you can then go away and write an adventure game or something like that. And when you get to the more complex programming, just remember that a lot of things are based around these value types here. Some things will be wrappers for these, so they will contain, you'll have structures which contain several different integers, for example. but underneath it all they are just 3 integers or 4 integers. So once again, I hope you found this informative, and I'm sorry for going on at the end there, but I thought that was quite useful for you to know if you were wanting to get into doing slightly more complex things with your time. So thanks for watching again, and I'll see you next time.